I will devote one more video on how to use the Pascal Triangle. There's a lot to talk about the Pascal Triangle, and for now, we are not yet talking about how to produce the numbers in this triangle. No, we will devote a separate video for that. But for now, our concern is how do you interpret the triangle and how do you use it? So the Pascal Triangle contains the numerical coefficients of a binomial when you expanded it to its integer exponent. So let's say, for example, x plus y raised to 4. So when you expand it, you will produce a degree 4 polynomial with 5 terms. Each of those terms would have these numerical coefficients: 1, 4, 6, 4, 1. Let's say, for example, x plus y raised to 6. If you expand it, it will produce a degree 6 polynomial. It would have 7 terms. And these are the coefficients of those terms. So you see, expanding a binomial requires a lot of writing. And if you have no organization with how you write it down, you can get easily lost. I will share with you my own technique. But I am not saying this is the best. Maybe you can devise your own technique to expand a binomial. Okay, x plus 1 raised to 4. So we will go to the Pascal Triangle and we will focus on the row for the degree 4 polynomial. This is a degree 4 polynomial because when you expand it, it will produce a polynomial of degree 4. And these are the coefficients. Okay, so this is how I do it. What I would do is I will write first the numerical coefficients. 1, 4, 6, 4, 1. But I will leave a gap there. I will leave a gap because I will still put something there. The next thing that I will do is I will focus on the first term. And then I will write it down. But I will write it down in such a way that the exponent is in decreasing order. X to the 4, x cubed, x squared, x, and then x to the 0, that's just 1. After that, you will pay attention to the second term. But in this case, the second term is just 1. So you will have 1 times 1 times 1 times 1 times 1. So this is it. This is the polynomial that arises when you expand x plus y raised to 4. How about x plus 1 raised to 7? So you will go to the row that corresponds to the polynomial of degree 7. This is it. And what are the coefficients of the terms of this polynomial? They are 1, 7, 21, 35, 35, 21, 7, and 1. So you will write now the polynomial. So again, this is my advice. I will first write down the numerical coefficients, but I will leave a gap because I will still write the individual terms of your binomial. And then after that, I will begin with x. I will write x starting from degree 7, 7, 6, 5, 4, 3, 2, 1. And you have here x to the 0, which is just equal to 1. So this is it. This is the binomial expansion of x plus 1 raised to 7. How about when x minus 1 raised to 5? This will produce a degree 5 polynomial. Okay, so that is the row that you will use. Now again, this is just my advice. And this is what I used to do. You can write x minus 1 as x plus the negative of 1. So this is going to be your y. It's negative 1. So how do you use the Pascal triangle and this binomial? You go to this row and you just write down the numerical coefficients. 1, 5, 10, 5, 1. Okay, the first term, you will write it in decreasing order of exponent. X to the 5, x to the 4, x cubed, x squared, x to the 1, x to the 0. Next, you will now pay attention to negative 1. Again, the pattern is the second term of your binomial will appear in your polynomial in increasing order of exponent. So you will have here -1 to the 0. What comes next after 0? It's 1. -1 raised to 1. And then -1 raised to 2, to 3, to 4, to 5. Look at the pattern here. X is in decreasing order of exponent, the first term. X is the first term of your binomial, whereas -1, the second term, is in increasing order of exponent. Then after that, you apply the law of signs. So this one is positive, this is negative, this is positive. -1 times -1 is positive. -1 raised to 3 is negative. -1 raised to 4 is positive. -1 raised to 5 is negative. So that's it. This is the polynomial that arises when you expand x minus 1 raised to 5.